All right, so let's go over these problems. In this assignment, I ask you to write an algebraic model to represent the situation, to define the variable. I want to know what is the value of the unknown. That would be the value x. And then I wanted you to model your solution on the number line. So let's get started with number one. It said Fred sold half of his comic books and then bought 8 more. He now has 13. How many did he begin with? Before we get started, you can do this on your Google Doc. You can take notes and submit your pictures. So there's a couple different options you have to get credit for this assignment. All right, so what is the variable? Okay, we're going to say x. And what does x represent? It represents usually the question, how many did he begin with? So x would be the number of comic books he started with. All right, now that we know what x is, now let's write our algebraic model. So what we're going to do is x is our number of comics he started with, and what happened? He sold half of those. So algebraically, we would write that as x divided by 2. So remember, in a Google Doc, we can use the underline to represent division. So x divided by 2. And then what happened? There we go. Then he bought 8 more. So he's going to add 8 to his collection for a total of 13. Let me get rid of this underline. So there's our algebraic model. X divided by 2 plus 8 equals 13. One other way that we need to be able to recognize to write this, if we're dividing by 2, so x divided by 2 is the same as multiplying by a half. So this is another way that we could write our algebraic model. All right, so now let's solve it. We know that what number plus 8 equals 13, and we know that number is 5. So doesn't that mean that x divided by 2 has to equal 5? So let's write x divided by 2, underline it. So what happened? How did we get there? Well, if we look up at the problem, didn't we subtract 8 from both sides? So that would be the next step. And I would encourage you guys to show me those next steps. So that means here's our 0 pair. 8 minus 8 is our 0 pair. And 13 minus 8 is 5. Okay, let me clean this up a little bit. All right, so now we want to solve for x. So what number divided by 2 equals 5? Well, we know that number is 10. Okay, that makes sense. So we know that x has to equal 10. So he started with 10 comic books. All right, so what step did we use in order to go from x divided by 2 equals 5 to x equals 10? Well, we multiplied both sides by 2. If I have a half x, I have to double it. I have to multiply by that denominator. So Control C. This is not perfect, but I'm going to use the bracket to indicate multiplication. So I'm multiplying both terms by 2. So 2 times x over 2 equals x, and 2 times 5 equals 10, and that's where our solution of x equals 10 comes from. All right, so we've solved. We know he started with 10 comic books. That makes sense. 10 divided by 2 is 5. 5 plus 8 equals 13. Perfect. All right, so let's now model our solution on the number line. We have one solution. So I made this a text box for you guys. Let's edit it. We have one solution. That would be 10. So I want a number less than and one number greater than. So one number less than 10 is 9. We need 10 because 10 is our solution. And one number greater than 10. We have exactly one answer. So that means we're going to have a closed solid dot over 10. And then I don't need the rest of this, so you can delete it. We don't need it. All right, there's your number line. Save and close. So we have our solution on the number line. We have our algebraic model. We've defined our variable. We have a solution. We have the steps to get x. All right, number 2. The sum of 3 consecutive integers is 135. So consecutive meaning back to back to back. So 1, 2, and 3 are consecutive numbers. 7, 8, 9 are consecutive numbers. 98, 99, 100 are consecutive numbers. So I want to know, when I add 3 consecutive numbers, which is the largest of the numbers? Well, there's our question. So let's let x be the largest number. So in terms of x, what would my middle number be? Because I need a small number, a middle number, and a large number. So if my large number is 15, won't my middle number be 14? So it's 1 less than the largest number. So it will be x minus 1. So that's my middle number. So my smallest number in terms of the largest number would be x minus 2. 2 less than the largest number. All right, so now I'm ready to write my algebraic model. I know that the smallest number plus the middle number plus the largest number equals 135 when I add them all together. Okay, that's not my algebraic model. My algebraic model will have variables in them. So I'm just showcasing the smallest number in parentheses. They're not necessary, but I just want to show you that x minus 2 represents the smallest number. I'm going to add it to x minus 1, which represents the middle number, plus x being the largest number. There's my algebraic model, but we need to combine like terms. So let's simplify this equation. So I see 3 x's, so that would be 3x minus 3 equals 135. Well, where did I get minus 3 from? If you look here, I've got a minus 2 and a minus 1. Negative 2 and negative 1 is minus 3. All right, so what number minus 3 is 135? Well, that has to be 138. So doesn't that mean that 3x is equal to 138? It does. So what step did we do to both sides? We added 3 because I want a 0 pair. Negative 3 plus 3 is 0. So I'm left with 3x on the left side, 135 plus 3, which is 138 on the right side. All right, so 3 times what number is 138? Well, that number is 46. So the operation that we performed was dividing by 3 on both sides. 3x's divided by 3 gives me 1x. And 138 divided by 3 gives me 46. So the solution is x equals 46. So what does that mean? That means my largest number is 46, my middle number is 45, and my smallest number is 44. And if you add up 44 plus 45 plus 46, do you get 135? You do. Can this be done without algebraic models? Yes, it can. However, we are at the point where we need to be able to write algebraic equations, algebraic models, algebraic inequalities, because that is a requirement of the 7th grade. All right, so let's fix our number line. Okay, same thing. I made a text box for you guys. Okay, we know that 46 is our solution. One number smaller, one number greater than. Okay. X equals 46, one solution, so it'll be a solid closed in because it's x equals 46. We don't need any of this stuff. Save and close. There's our number line. All right, we have modeled this problem on the number line. Modeled the solution on the number line. All right, number 3. Number 3, I gave you guys these type of problems around Thanksgiving time. We made tables. Tables are a great way to solve these problems. But we can also write algebraic equations, algebraic models, and that's what I wanted you to do on number 3. So let's talk about number 3. It says, a computer is on sale for 15% off. Its sale price is $255. What is the original price of the computer? All right, well, X is the original price of the computer. Do not forget to define your variable. All right, whether you're going to the mall or going somewhere where you get a discount, how is the sales price calculated? It's calculated by the original price minus the sales price, and that will equal, I'm sorry, original price minus the discount is equal to the sales price. All right, well, we know our original price is X. Our discount is 15%. So how do we represent taking 15% off algebraically? Well, 15% as a decimal is 0.15. And if I multiply my original price by 0.15, that gives me the discount because I'm taking 15% of the original price. So we would represent that as 0.15x equals, and we know the sales price is $2.55. Okay, I've got some like terms that I need to combine. I've got 1x, okay, one whole x, like one whole dollar, minus 0.15x, like 15 cents. What's 1 minus 0.15? It's 0.85. I want you to think about this real quick. If we take 15% off of the original price, 15% off the original price, our original price being 100%, what percent of the original price are we actually paying? We're paying 85%. So by combining our like terms, that gives us 0.85x. And also it makes sense in the fact that we're paying 85% of the original price. And so that's our simplified equation. Now to solve for x, we're going to divide both sides by 0.85. So when you calculate dividing by 0.85 on both sides, the original price of the computer is X equals 300. So it's equal to $300. Let me just clean this up a little bit so it's not all jammed together. All right, so there you go. I have one price. The price is $300. If you were to work backwards and check your work, and you were to take 15% discount, 15% of $300, you would get $45, and 300 minus 45 gives us the $255 computer that's on sale. So always go back and check your work. Does your answer make sense? All right, let's make our number line. Okay, our solution is $300. One less would be $299. As long as your scale is okay, I don't mind what numbers you put, but as long as they make sense. 301. We have one solution, so we're going to use the closed dot. That means x equals 300 on the number line. We don't need any of these others. Save and close. And there we go. Number 3. All right, number 4 is a little bit different because of the way that it's worded. So over the summer, a carnival comes to town. You decide to go with some friends. Admission into the carnival is $3 and each ride is 50 cents. What is the possible number of rides you can go on having $12? So if I had $12 and I went to the carnival, I was pretty sure I'd still go on 0 rides. So there's a possibility. There's many solutions here. You don't have to spend all of your $12. So we're going to use an inequality to represent our algebraic model this time. Okay, so let's define our variable. X is going to be the number of rides we can go on. All right, so $3 to get in plus 50 cents per ride. And we have $12. So that means we've got to spend less than or equal to $12 at the carnival. So we're going to go to insert, some special characters, less than or equal to. Okay, it's there. $12. So now let's solve for x. Let's figure out how many rides we can go on. So we know we can spend $9 on rides. So we'll show that algebraically. We're going to subtract 3 from both sides. 0.50x is less than or equal to, okay, it falls all the way down, $9 because 12 minus 3 is $9. So a half of what number, if each ride is 50 cents, so a half of what number of rides equals $9? Okay, it's not 4.5, it's going to be 18. So let's just show that we're dividing both sides by 0.5. A half. The division is indicated by underline, fraction bar. So that means X is less than or equal to 18. That means I can go on 18. The maximum number of rides I can go on is 18. But I can go on 15 rides. I can go on 11 rides. I can go on 6 rides. I can go on 5 rides. I can go on no rides. So all of those numbers needed to be included as a solution on my number line. You can't go a fraction of a ride. So we're not going to have a solid filled in line. All right, so I'm going to make my box bigger because I need to account for 0 rides, 1 ride, 2 ride. I've already got 3. 4, I'm just going to backspace. 5, I can go 6, 7, 8, 9. I can go on 10 rides, 11, 12, 13 rides, 14, 15, 16, 17, 18. Okay, perfect. All right, so now let's just start filling it in. I can go on 18 rides, 17. I can't go on 17 and a half. That's why there's solid filled in dots on top of each of the whole numbers. 15, 14, 13. Okay, I know this is a lot, but you'll be okay. I promise. 11. A lot of other people have done it too. 8. 7. 6. 5. 4. 3 rides. 2 rides. There's my last dot. Okay, Control C, Control V. I've solved that problem. 1 ride and no rides. Those are my possibilities. So this is my solution on the number line. So we don't need any of this stuff. We can delete it. All right, we're done with number 4. We've got our algebraic model. We've defined our variable. We have our solution on the number line. All right, last one, best one, number 5. All right, Brenda has $5 in her bank account. Every week she withdraws $40 for miscellaneous expenses. How many weeks can she withdraw the money if she wants to maintain a balance of at least $200? That's the key phrase, at least. And if you look up at the top, I've provided a chart for you for keywords for inequalities. At least means greater than or equal to. So she needs more than $200 in her bank account. All right, so let's write that algebraic model. X is going to be number of weeks. All right, so $500 in her bank account. She withdraws $40 per week. At least is going to be greater than or equal to. She wants more than $200 in her bank account. So I'm going to type greater than in my special characters. Greater than, she wants more than $200. So let's solve it. So we would subtract 500 from both sides. Whoops, not 5,000, 500. So it's not 40x, it's negative 40x. Always be mindful of the sign in front of the number. So it's minus 40x. Negative 40x is greater than or equal to negative 300. That might throw you off, but it will work out. Okay. So in order to solve for x, I need to divide both sides by negative 40. Negative 40x divided by negative 40 is x. Do you guys remember from the gizmo from a couple of days ago, what happens when you multiply or divide an inequality by a negative number? What happens is you change the sign, it flips. Okay, so it will no longer be x is greater than or equal to, it will be x is less than or equal to. It's because of a reflection on the number line. I gave a simple explanation on Monday's video. So it would be x is less than or equal to 7.5. And to me, that makes sense because if I withdraw $40 for more than 7.5 weeks, if x is greater than or equal to 7.5, Brenda's not going to have any money. She's not going to have at least $200 in her account. So to me, that makes sense. Okay, when you multiply or divide an inequality by a negative number, you change the direction of your inequality sign. All right, so let's model this on the number line. Now, there are fractions of the week. Today's Wednesday. Half a week is Wednesday. There's Tuesdays. That's a fraction of the week. So we're going to represent our number line with a bolded line to indicate everything between 0 and 7.5. I put some spaces in between here. All right, so it's or equal to, so that means over 7.5, I will have a solid filled in line. I know that I'm going to spend more than 0 weeks, so I'll have an open circle. Okay, and I don't want either one of those because arrows indicate that it goes on and on forever and never, never. And then this is not the case. So I'm just going to go and add a line from 0 to 7.5. Let me make it red so I can see it. So every day in between 0 and 7.5 weeks is a possible amount of time she can withdraw money and still have $200 in her bank account. All right, if you have any questions, email me. Make sure you submit your answers and have a great day.